What's up guys, Chris here. Today we're going to try to make a new arbor for this blade I've been using on the Lagoon mill to cut various metals. The little universal arbor that I had gotten a while back, the little half-inch ER collet, is just not working out. As you can see, it's spun in the collet many times, despite being as tight as I could get everything. This does not have a key in it. It's a universal arbor, so it's spring-loaded washers in there, but no key. So this will spin on this. This spins in this, and I don't think the TTS collet spun in the taper, which is nice. But I've got these sections of bar. I'm going to try to make my own out of this. The first one I cut too short because I was thinking I had a lathe, so I would be able to just cut it a little bit longer than needed, but I'm actually going to need about an extra inch so I can hold it in the mill because I don't have a lathe. So I guess we'll see what happens. Good enough. Huh. All right. Good enough for me. Flip her over and do the other side. Now, I don't know what kind of steel this is, but it seems to cut pretty well. It was scrapped from an automated machine, but it wasn't anything critical. I think they were just for stops or something like that, so it's probably just a mild cold rolled steel, probably. I don't really know. Won't be anything too fancy. Huh. It is rough through the center. Seems like it'll do alright. As you can see, that is this is the only semi-stubby half-inch end mill that I have. It is pretty dull. It was in the end-of-life bin. So I think it'll work fine for what we're doing here. Because this part is actually just to be held in the collet. Once we're done, that'll get cut off anyway. So as long as it gets us a nice decent bore, we'll be alright with it. But I'm gonna turn the coolant on, let that run. It says it's gonna take like 45 minutes or so, so we'll come back when that's done. Alright, all done. Actually, it turned out pretty nice. 3/4 inch collet. Yeah, 0.7495. 0.752. 0.752. I don't know, it's hard to measure with these. Seems like it's fine though. It's just an R8 collet from the lagoon. Fits just fine. So hopefully it'll fit in here just fine. Because the next step is that has to go in the spindle. Alright. Pop this out. There we go. See if it looks concentric. Yeah. Yeah, about 1,000. About 8/10 really. This is pretty darn good. I'll take it. So I found this neat post processor for the Slant Pro lathe that I think somebody modified. I'll have to put a link in the description underneath. But they've got an option in the post processor config to use the mill as a lathe. And I just ran a quick test. So while I'll look through this, I'll run it again. So you have your tool mounted here. And it seems like it should work. Just going through my box of old lathe stuff. I've got one tool holder. Technically that would need to be mounted this way on the center. No, well, spinning the other way. It would also be the same as running probably change that axis because I want it to go just because it's easy to shut that off. I don't want to turn the vise if I don't have to. That should be fine though. Yeah, I should be able to make it go either direction. So that'll go in the vise. That should actually be all we need. So let me get all that stuff set up and we'll be back. So I think I got this figured out. It took quite a bit of back and forth on the computer to try to get things oriented right, but I think this is, if you think of this as just a lathe tipped up on an end, this will still spin clockwise, and you'd normally be feeding from this way, you know, cutting up like that. So the tool goes upside down, sticking out of this side. Something like that, you know. So now I need to find my center, which I guess I will just do kind of the old-fashioned way. It's probably close. It's actually a bit heavier cut than I was planning on taking, but it's nice that it didn't seem to complain. Oh, that's real close. In fact, I'm going to leave it there. Well, maybe I won't. Let's see. At least set that as 0 for now, so I don't lose it. Let's try one more cut. We'll move 2/1000 this way and see if that's any better. There's just the tiniest little thing. Oh wait, no, we were way off. Try that. It's cutting really well. I mean, it's a big chunk of steel, I guess, but I thought it'd be a lot more chattery and just generally terrible. Alright, so that's centered. So our Z height, well, let's get our X first. So that is our X and Y. Now Z, I'm going to start up here and see what happens. We'll say this is 0 here. Alright, let's see what would happen if the tool was up here. Oh, let's just see. Move it over to here. I think it's acting like it's backward though. I think it looks like it's trying to cut from the middle out, which is not great. But that's probably just a setting somewhere. So let's set this as 0. Alright, let me get this figured out. The Z, changing the Z height, the Z0 doesn't seem to affect where it's trying to turn from. So X is -746. Let me do some figuring, I'll be back. Alright, so we should be good to go. Let's just see what happens. I'm only doing, I think, 10,000 or 15, 20,000 depth of cut. I don't remember what it is now. I'm going very, very light for obvious reasons. We'll see how it works. And it says it's supposed to take 14 minutes, but if it goes well, I'll up the feed rate and stuff, and we'll see. So let's start. I wish it wouldn't do this. Nice little air pass, I guess, is not a bad thing. It shouldn't be. It should be cutting here according to the simulation, but that's... I feel like that's wrong. Why, Interesting, because it looks right in the computer, but for some reason it's not correct here, obviously. So I need to go figure that out. X, negative direction? No. And I'll have to flip that insert. I don't know what its thoughts are. Why were you doing that? I'll be back. Alright, so I was trying to avoid this specifically because it wouldn't be good for filming, but the only way I can figure out how to do it and get it to behave the way I want, not the way I want, the way that it has to in order to work. Yeah, it's just everything has to be flipped. So it moves in the right direction now. So let's give it a shot. Get our Z. Actually, I might have to edit the code and switch the clockwise, counterclockwise, but we'll see. Alright, this should all work now. Maybe. Let's find out. Aw, I was surprised. That's only 20 thousandths deep. Alright, well, it might be a too much depth to cut thing too. Can't tell if that already fried that insert or not. I thought I heard a little crunch. Can't see. I got a ton of these inserts though. It's funny, I actually have a fair bit of carbide lathe inserts, but no lathe, and really only this tool. Yeah, it's borked, but maybe we'll let this just run. Let's see, so should probably do the math and see what that should really be running at. Evidently higher than 500 RPM. Alright, let me do the math. I'll be back. Alright, so it's actually pretty close. Just guessing. I was right at about 200 surface feet per minute. I think it was 15 thousandths per revolution, which is, now that I think about it, dumb. But, you know, whatever. So I changed it to 5 thousandths per revolution, doubled the surface footage because it's carbide and it probably is fine. And it'll get us going a little bit faster. That was going to be like 20 minutes at 500 or 500 RPM, 200 surface feet per minute. So I've also got a different insert in there. When I was replacing the screw, I didn't realize the first inserts I picked, I mean, I knew they were thicker, but it was kind of canting the little clamp over a bit, so I got a thinner insert, or a thinner, yeah, insert, just because. So I've touched off everything. Let's try it again. Bring the speed down a little bit too. That's not great, but and look at that. probably should tip that tool up a little bit. Alright, so I said to leave 15 thousandths. It's supposed to be 75. So that's 75 plus 0.03, so it should read 0.78. So it's reading 787. Seven, 7, 5, 8, 5, 6, 7, 8. All right. Well, let's take off the rest of that. Let me. Oh Jesus! What did? No, whatever. You know, I'm just gonna leave it. That end doesn't matter. I don't know why it didn't face all the way to the center. I can always clean that up manually too. All right. Let me have to take the rest off. Add some oil just because it's the last pass. Maybe it'll make it a little nicer. Right, it's got to do this. I hope it doesn't hit the chuck. Alright, well, I'm going to stop it there. So it's getting a little too close for comfort. Alright, so we should have, it shouldn't quite be 0.75 yet. It's a nice-ish finish. Still got 11 thousandths. Just double check. Yep. Wow, there's a, let's see if I can show you this. There's a huge difference in, hold on. A huge difference in surface quality between, it was spinning at 1,000 RPM, but the surface speed of the wider portion, look at the difference in that. That looks great. This looks like crap. I may actually take off another thousandth or so at a much higher speed and see if I can make that look pretty. It's nicer. I forgot, because there's a separate, your speed, you put in the software the surface foot you want to run at, and oh yeah, and it's, so you have your RPM and your feed per revolution. So because I upped that, I needed to lower the feed per revolution to get it super nice. So let me drop the feed down to like 6% and we'll run it again. Wow, that wasn't even really a spring pass. I thought there'd be, a little bit left, but it really didn't take off anything. Alright, we're technically a couple thou under where I'd like to be, so I'm going to just leave it at that. It should still be plenty good. See if I can get this to, here we go. That's pretty nice. This thing, I don't know why it left this, it didn't face that off, but it's not a big deal because that doesn't touch anything. So now flip it back over again and put it back into the spindle. So this fits in there now. That's actually a little tight in that one. So it seems to stick a little bit up as you go farther. There's probably some gunk and crap. Yeah, it's scraping up the top of the shank. So there's something in there that farther up in this collet that's messed up, but that's fine. This isn't the machine it goes in anyway, but I do need it to hold on so we can finish the rest. Now, if I had a parting, I have a parting tool, but I don't, well, let's try it. Probably it'll be okay. This may work out very badly anyway. Which is fine, we can get that nub off with other tools, but this will be the fast way if it works. It works. I think I even ground that bit, which is doubly surprising. Up the RPM for this. Yay! It worked. Alright, so here's our other problem. This old Arbor that was, I mean, it was pretty cheap. It was like $15 or something, but I tightened it up evidently to the point where I've actually sunken in the top of that head. And despite putting anti-seize on the bolt when I put it in, it will not come out. I've tried an impact. I've tried all kinds of stuff. So we're just, since this is trash anyway, the blade is actually still just fine. No chipped teeth or anything that I could find. We're just gonna mill the top of this off to get our blade back out. Yeah, it's not hardened. Guess that means it's free. Or we'll just have to hit that with the angle grinder, I think, to get the rest of that. I don't think. No, it's just gonna spin. Alright, I'll hit it with the angle grinder to cut this last little bit off and we'll be back. Alright, that's what's left of it. You can see it's got these springy steps, so it fits multiple multiple Arbor sizes, but it's a little wimpy. So, but this is what we needed. I wanted to double check. I think I made this 1 inch, but I don't remember what I bored that out to. So it's probably wise to check. Seeing as this arbor is made specifically for this blade. Yep. 9995. 103. 102. 99. Alright. May not be perfectly circular anymore. This did spin in the collet more than once, or spin in the arbor holder more than once. I don't know if that wallered it out a little bit or not, but it should still be fine. And we're putting pins. That's the big difference with this one, is it's going to be pinned, so it won't be able to rotate anymore. So we'll be good, but yeah, 1 inch. All right. It's a shame there was an option for constant surface speed, but it's turned off in the mill configuration for some reason. I also angled the tool up ever so slightly on this one, so it wouldn't, when it goes to cut the floor, it shouldn't bottom out on the tool. Ooh, sparks. Don't mind seeing sparks when it's carbide. This tool definitely doesn't do as well facing as far as chip breaking goes. I don't know if that's typical or not. I love how you can see those chips change color in the air. Guess I probably should have given it a little bit more of a upward tap. Alright, well, we're close. Ow, my face! Ow, I stabbed myself right by the ear. Just trying to see if... I think the corner of that is chipped a little bit, yeah. That was not quite enough. tool angle up here. This is a 90-degree tool, so in theory this is straight with or parallel with this. So when it goes to cut that face, it cuts the entire width right there. And there's not nearly enough torque on this machine to do that. So I bumped it up. These just fell down a little bit. I bumped it up a little bit so it wouldn't be like that. But we'll bump it up a lot. I just need to. Oh, let's see. I need to re-get my face, which is easy enough. But then I have to go change CAD because it's not the. That's better. I freaked out, but it's fine. Now what we're actually going to have to do is use because this has a radius on it, we need to use the parting tool again to get a nice flat surface for this. That's close, but we'll just do this manually. Here we are. Alright. You know what? We're just gonna mill it because I still have to do all the other operations on this side in the mill. So I'm gonna get set up for that. It doesn't have. This isn't like, you know, a high-speed, perfectly balanced tool anyway. It's only gonna be running at what, 90, 100 RPM. So it doesn't have to be perfect. And it's gonna be a hell of a lot easier just to. So I have to pick up the concentricity of this anyway, so I can drill the hole for the bolt and drill and ream the two spots for the pins. I might as well just cut this little boss for the bore at the same time, make my life easier. So I will be back in a little bit. Alright, so I think that'll be it for part one. We'll come back next time and do all of the milling features in this, as well as mill out the cap, and go from there. So, thanks for watching.